Okay, here's the next video. Um, this one is the graphing radical functions. So we're going to sketch the graph and then identify the domain range in/turning point of each function. Recall that the square root functions will have an endpoint, and the cubed root functions or odd root will have, the square root will have an endpoint. The cube root will have a turning point. So in order to graph them, we first need to get a little table going here. So this will be our y, and this will be this will be our x. This will be our y, and we just need some points to use. So because this is a square root and there's nothing else inside the square root, I'm going to use nice, neat, perfect squares. So I'm going to use 0 because we're not going to start with negatives, so we can't take the square root of negatives, at least, and stay in real numbers. So square root of 0, the square root of 4, and 9 should be enough. So if I plug 0 in here, that's 0, minus 3 is a negative 3. The square root, I forgot 1. Well, we'll squeeze 1 in there. The square root of 1 is 1. 1 minus 3 is a negative 2. Square root, so plug in 4. Square root of 4 is 2. Minus 3 is a negative 1. And then 9, and square root of 9 is 3. Minus 3 is 0. So we have 0, negative 3. We have 1, negative 2. Then we have 4, negative 1. 4, 0, 1, 2, yeah. I feel like that's wrong for some reason. Give me 0, negative 3. Square root of 1 is 1, minus 3 is negative 2. Or, yep, I guess that works. Not wrong. 0? That still feels wrong, and I don't know why. Maybe it's just late. Square root of 4 is 2. 2 minus 3 is negative 1. Yep. Square root of 0 is 0, minus 3, 1, square root of... Okay. And then 9 and 0. So it goes way up here. 2, 4, 6, 8. So it's off the graph a little bit. So that's what our graph will look like. Our endpoint is right here. So our endpoint, so the domain, start the domain. Let's go straight down the list here. Our domain, the lowest x value we can use is 0. So it's from 0, and our highest x value is infinity. So it's all the way to infinity. So 0 is less than or equal to x, which is less than infinity. Or if you want to write it like closed 0, infinity, that is also fine. Okay. Range. Our lowest number is negative 3 right here. So negative 3 is our low point. And our high point, this would go all the way to infinity. It would take a long time to get there, but we can go all the way to infinity. Or you can write it as, so or closed negative 3 to infinity. The endpoint. The endpoint is whenever this radical spot zeroes out. So it zeroed out at 0 because there's nothing else in that radical. So our endpoint is 0, -3. That's our endpoint right there. And then we have, what's the next? Domain range endpoint. If you want to add in behavior there as well, as x approaches, x doesn't go to infinity. The lowest point in the domain is 0, so we'll have to do, so because our lowest point here is 0, if we want to do in behavior, as x approaches 0, because that's the lowest point there, so keep that in mind. Y approaches, well, at 0, y is -3. -3. So that is that bit there. And then as the other end of the spectrum, we have infinity. As x approaches infinity, y also approaches infinity. Okay, moving on. The square root. So do this all over again. So when x is 0, again, we're going to start when this is zeros out. So that would be 0. There's nothing else underneath here. So the square root of 0 is 0. Minus 0 minus 1 is -1. So then we'll go to the next perfect square. So that's going to be 1. The square root of 1 is 1. Minus 1 is 0. The next perfect square is 4. So the square root of 4 is 2. 2 minus 1 is a 1. And so through next perfect square is 9. And the square root of 9 minus 1 is 2. Is 2. So we'll plot these real quick. 0, -1 is right there. 1, 0, right there. 4, -2. No, 4, 1, right there. I plotted this one wrong. That should be 4, -2. 3, 4, -2. So that should be right up there like that. Sorry about that. That's what was throwing me off there. That's what threw me off. XY. Oh, and then we have 9 and 2. So 9 is out here and 2 is about right there. So we got this guy right there. So again, that's our input. Our domain follows the same structure. We start with the lowest point here. So that is 0 included, all the way to the highest point, which is infinity. Our range is the lowest y value, which is -1, and it's included. So we're going to close it all the way to infinity as well. And because it's a square root function, it has an endpoint. I'm just going to abbreviate that AP, which is going to be where it starts right there at 0, -1. And then we have our end behavior. As x approaches, its lowest point in the domain is 0. Y approaches, well, that's also approaching, as we go to 0, it's also approaching the lowest spot in the range, which is -1. And as x approaches the other end of its domain, infinity, y is approaching infinity as well. Okay, this one. 4 to the cubed root of x minus 1. So we're going to have, one second. So we're going to have, create our table again. This time we're not going to have a starting point because it's a cubed root function. We're going to have a turning point. So I like to start at the turning point, and the turning point is whenever does this equal 0. So when does the radical part equal 0? And since I have a negative 1 here, that means the turning point, I'm going to put it down here in the middle, is going to be positive 1, because 1 minus 1 is 0. So when that zeroes out, that's our turning point. And then 4 times 0 is 0. So we get 1, 0 as our turning point. Turning point. And then we want to get perfect cubes in here. So we want, when x minus 1, we want to know when x minus 1 obviously equals 0. 1 is a perfect cube, so plus or minus 1, because we can do negatives with cube roots. We also, 1, and then we need the next cube, 8. So plus or minus 8. And then after that, we tend to go off the graph. So if we get these 5 points, we should be good. So 0 is, that was negative 1. We already got that one. No, not negative 1, positive 1. So that was when x equals 1. We want, so x equals positive 1. That means x is going to be 2, or it's going to be, so to equal negative 1, it could be 0. So we're going to want the point 2, and we want to use 0 as well. And then for x to equal positive 8, so 9 minus 1 would equal positive 8. So we're going to use 9, or for x to equal negative 8, or the radical to equal negative 8, we would have to say negative 7. Negative 7 minus 1 is negative 8. So those are the other points we want to use. 9 and negative 7. That way our radical always comes out nice and clean. So when x is 0, that makes that negative 1. Negative 1 cube, or the cube root of negative 1 is negative 1. And so negative 1 times 4 is going to be negative 4. We have this is negative 7. That makes that negative 8. So negative 2. The cube root of negative 8 is negative 2. Negative 2 times 4 is a negative 8. 2. So if I plug in 2 here, 2 minus 1 is 1. The cube root of 1 is 1. And then 4 times 1 is 4. And then I plug in 9. 9 minus 1 is 8. The cube root of 8 is 2. And then 4 times 2 is 8. So now I can plot our points. 1, 0 is right there. I have 0, negative 4, so right there. I have negative 7, negative 8 is right there. 2 and 2, 3, 4. And then I have 9 is off the graph a little bit, and then 8 is right there. So this looks like something like that right there. Okay. Domain for cube root functions is x is in all real numbers. The range is also awesome like that. That's when y is in all real numbers as well. There is no endpoint, so we don't have to worry about cutting it off. And there's no asymptote with these either. They all real numbers all around. So it's a cubed root function, so it has a turning point, and that's going to be at 1, 0. You see it's the most vertical part of the graph. And then we are going to have in behavior. So as x approaches the low side of the domain, which is negative infinity, y is approaching, so y is going down. So it's also approaching negative infinity. And as x approaches the upper domain, which is positive infinity, y is also going up at the time, so positive infinity. Okay, one more on this page. So number 22, x plus 6. So our turning point here, so we need to find all the points when x plus 6 is equal to 0, or it's equal to plus or minus 1, or plus or minus 8. We want to find those points there. So, sorry, I have to keep pausing the video to cough. Where was I? Here we are. So I need to know when x plus 6 equals 0. So that is when x will be equal to 6. So that's also our turning point. So we want to use 6 as our turning point. When is it positive 1? So when is x plus 6 positive 1? That means x is going to be a negative 5. So negative 5 plus 6 is positive 1. So we want negative 5, or when is it negative 1? That would be a negative 7. When is x plus 6 8? Well, x plus 6 is 8 when x is 2. And when is x plus 6 negative 8? Well, that would be negative 14, which will be off our graph. So we want 6. Oh, sorry, we want negative 6. That should be negative 6. Negative 6. So we want negative 6. We want negative 5. We want negative 7. And we want 2. So that will all give us nice clean numbers. So our turning point, so negative 6 plus 6 is 0. The cube root of that is 0. 2 times 0 is, again, 0. Negative 7 plus 6 is negative 1. So that would be negative 2. And you multiply it by 2. Negative 5 plus 6 is positive 1, which would give us a positive 2. And then that's going to be 2. 2 plus 6 is 8. Cube root of 8 is 2. And 2 times 2 is 4. Yep, 2 times 2 is 4. Could we go with, so the next cube root after that is 27. Nope, that's way too big. That was x, that was y. So domain and range are both, x is in all real numbers, y is in all real numbers. Our turning point is when we zeroed it out there. So it's going to be that first one we did when x is negative 6. Negative 6, 0. And then as x approaches negative infinity, oh, I guess we need to graph it real quick. Negative 7, negative 2. Negative 7, negative 2 is right there. Negative 6, 0 is right there. Negative 5, 2. Negative 5, 1, 2 is right there. And then 2, 4. 1, 2, 1, 2, 3, 4, right there. So this graph looks like that. and then it'd level out over here, way over here. So as x approaches negative infinity, y is also going down and approaching negative infinity as well. And then as x approaches positive infinity, y is going up and approaching positive infinity also. Okay, that concludes video 2. I'll see you guys in video 3.